Hello, and thanks for joining us at the late session of day two of IMF 2020. If you're just joining us, my name is BJ Farrar. I'm with the Getty Museum in Los Angeles, California. I hope everyone had a chance to see Richard and Jesse's poster, as well as maybe take Brett's shop tour at their fabulous new space at the MFA Boston. Please note, your microphones will be muted and cameras turned off during the presentations. We were recording all the presentations to be eventually posted to our IMF YouTube channel, so we want the audio quality to be as good as possible. We will also be live streaming today's presentations on YouTube at the IMF's channel. If you have any specific questions, please use the Q&A function on Zoom. If you have a question for a specific person, please use their name so they know it's directed to them. We will try to address as many questions as we can in the amount of time that we have at the end of each presentation. Any questions that we can't get to during the Q&A can be brought up during our after parties or through the Slack app, #day2latesession. Also, feel free to contact the presenters directly. Each presenter's abstract and bio are on the IMF website. Before we start our presentation, I'd like to gratefully acknowledge the Native peoples on whose ancestral homelands we gather, as well as the diverse and vibrant Native communities who make their homes here today. And now for our first presentation, brought to you by Adam Bradshaw of the Smithsonian Institution's National Air and Space Museum in Washington, D.C., who will speak on digital fabrication in the museum space.
Hello and welcome to this presentation on digital fabrication in the museum space. My name is Adam Bradshaw. I am an exhibit specialist at the Smithsonian Institution National Air and Space Museum. Here's my contact information in case anybody needs it. So I'm going to be talking about digital fabrication, and for the purpose of this presentation, I've identified three key aspects that I want to discuss. Digital fabrication as a system that uses gathered data for analysis, design, and fabrication. As a design workflow that incorporates CAD and CAM towards production. And as a means of rapid prototyping. I'm going to show examples of our data gathering process, our design workflow, and our production output. In terms of data, we've used medical imaging to analyze object interiors that were previously inaccessible. We've also incorporated 3D scanning into our object handling and mount making workflow. Now let's look at ways in which we've used medical imaging for creating a new mannequin system. This is a CT scan that was taken of a spacesuit glove. We used a DICOM viewer to analyze the data set and determine the best areas to create a mounting mechanism that would allow the glove to be displayed as though it were attached to its suit. Within the DICOM viewing software, we created 3D representations of the data set and then isolated the relevant areas for development of the mount. From this high contrast model, we could then examine the glove's interior and determine fixture surfaces the mount could attach to. We also use CT scanning to analyze the interior voids of the spacesuit's boots. Because of the suit's construction, these areas had previously been inaccessible for development of proper foot support. Using the tools within the DICOM viewer, we could create cross-section views that showed us the boot's interiors and the obstructions we would need to work around. Now let's look at 3D scanning examples. Here we have a scan being taken of an existing mannequin that was no longer going to be used. We scan the mannequin for size and proportion reference in creating a new display form. We are currently using a 3D scanner that captures both geometry and color, allowing us to create high-quality scan models. Within the scanner software, multiple scans can be combined together to create a 3D model. This allows us to create 3D models of objects on a variety of different scales. Now let's take a look at the design process, including working with STL models and 3D CAD software. If we go back to our glove example, we can begin the process of exporting the 3D model as an STL file. From the DICOM viewer, we can create a surface model of the isolated parts of the glove. We can also see how our surface model compares to the original data set. The model looks good and is now ready for export. We've brought our model into a mesh editing software. As you can see from the example, our 3D model is made up of millions of small triangles. Not all the information is needed, so we're going to isolate and trim the parts that are unnecessary. From there, our model can be brought into a CAD program, and design ideas can be evaluated against the scan data. We also use this workflow for developing a foot support for the boots. We knew that space was limited, so we wanted to develop a mannequin foot that would turn and pivot as it reached the bottom of the boot. Now let's look at how we create 3D CAD models directly from scanned data. Here we are scanning an object to create a support mount for a new display. With the scan model in our CAD software, we can use the surface to create support brackets. In this example, the scan surface of a fender was used to sculpt an ethafoam support for it. Likewise, the surface of the shaving cream tube was scanned, and then a sheet metal forming block was machined to make the mount. Next, let's take a look at production. This includes subtractive manufacturing, or CNC, and additive manufacturing, or 3D printing. Going back to our previous example, the sheet metal support bracket that was designed was then flattened and turned into a shape that could be cut using a laser cutter. Additionally, we designed forming blocks that were then cut on a CNC router. Lastly, a 3D printed facsimile of the object was created so that the formed mount could be fit checked against it prior to fitting against the object. This workflow has been repeatedly used to limit the amount of direct contact needed with an object. FDM 3D printing has been used for creating object facsimiles to aid in the mount making process. It's also been used for creating tools, jigs, and fixtures. In areas where engineering tolerances are needed, we've relied on SLA 3D printing for creating complex prototypes. CNC production has been the cornerstone of much of the final products created through digital fabrication, allowing us to create complex shapes in a variety of different materials. As example, this mannequin system that was developed for the spacesuit project could not have been created without the use of CNC production. In summary, I'd like to go over some of the key aspects of digital fabrication and how it can benefit the museum world. First off, digital fabrication has the ability to handle complex and challenging mount situations. It also increases the speed of rapid prototyping. It is reliable and repeatable, and allows for greater collaboration worldwide. Lastly, it's also scalable, meaning it can be used for one-off production all the way up to large-scale manufacturing. This concludes the presentation on digital fabrication in the museum space. I hope you have enjoyed it. Thank you to all the IMF organizers, staff, and volunteers that helped make this event possible.
Wow, thank you, Adam. That was a fantastic presentation. Let's open it up for some question and answers. I know I have a few. Our Q&A facilitator is Lauren Osman.
Hi, Adam. Thank you.
Hey, Lauren.
Thank you so much. That was so interesting and a really beautiful presentation.
Thanks.
Enjoyed it. Thank you. So I'm just going to go straight to the Q&A chat, and I saw that you had answered something live, and so I'm just going to repeat it out loud so that everyone is on the same page. So the first question was this in-house or third-party CT scanning? You answered, you used the CT scanner at the National Museum of Natural History. Yep. The second part of that question you didn't answer, though. I'm wondering, does it affect the budget?
It certainly could.
Yeah.
You know, in the past, I would have said if you're looking for a local CT scanner to be able to use for projects, consider contacting your local hospital or partnering with universities, particularly medical universities, that might have that technology in-house and be able to facilitate those requests. With everything going on right now, I'm not sure that that's probably as feasible as it had been in the past. I know that it's also a technology that's used a lot in large zoos. So it's used particularly for care and treatment of the different animals within the zoos. So that might be another avenue as well. But we are fortunate with the Smithsonian to have that technology in-house and to have that ability to cross-share technology between the different museums.
Great, thank you. And maybe I'll just kind of piggyback on that question. I'm just wondering about how user-friendly the software is, because I'm assuming like with the other SI unit that you worked with, they helped you with kind of the scanning and like the different kind of methods of data acquisition. But then at the end of the day, you're probably the one that's going to be manipulating the data, right?
Yeah, so the example of the glove, that was the raw DICOM data set coming into the program. So depending on how the data is scanned, you can wind up with a data set that's really easy to work with. And that screencast of me going through and creating the 3D model, that was, I believe, all in real time. So a lot of the software has become incredibly user-friendly. There are a lot of different DICOM viewers out there that are free, and they've become more and more simplified, I think, in a lot of ways, because they understand that it's not just being used for medical assessment and imaging anymore. It's being used by a bunch of different people for a lot of different things. So some of the software is pretty easy to use. There are a lot of really good videos on YouTube showing people doing similar things in their methodology of how they access the DICOM data set and then how they extract the information that they need for 3D printing or for CNC production.
Cool, thank you.
Yeah.
So our next question is from Evan, and they're asking, what is the handheld photogrammetry scanner called?
So the one that was in the example is the Artec Leo. We were fortunate to be able to write and receive a grant to purchase 2 new scanners this year, the Artec Leo and also the Artec Space Spider. The Leo has been a real game changer for us because of it being a handheld scanner, and it also captures both really good texture quality and geometry, but also the color and photographic quality. And it's been used a lot within, I'd say, probably the past 6 months for a variety of different projects. And it's allowed us to scan things kind of from, I'd say, like the microwave size up to, the other day we did a Rolls-Royce jet engine. So you have a pretty wide range of what you can scan with that.
Very cool. Thank you. So our next question is from Nan. And I realized that a lot of the equipment that you're working with is through, or it was the CT scanner that was through Natural History.
Yes.
Okay, I'm just going to ask the question. So what are the costs for equipment and software? How long did it take for you to learn to use it?
So the cost can vary. There are certain scanners, not CT. CT scanners can be very, very expensive. And they also require a dedicated room space to be set up. They require shielding to be part of the room setup, and operation of them can be pretty taxing. But the handheld scanners, they range in price. There are some on the market now that are around 7,000 to 10,000. I know that the Artec scanners tend to be in the range of between 15 to about 25. There are some other units, there are some other units out there that could be upwards of 60 to 80,000. So there is quite a wide range. One of the things that's also developed now is there are more and more rental companies that will rent you the equipment and the software license to be able to process the scan data for whatever length of time that you need it for your project. So depending on where you live, there might be rental equipment available that might be a more cost-effective solution. In terms of learning the various different programs, it's, it's kind of been a lifelong process for me. I didn't used to do much of anything with digital CAD. I didn't used to do much of anything computer-based. My background is in sculpture. I, always thought that if you were spending your time on a computer, you were missing out on, all the fun of making things with your hands. Mm-hmm. But it is a process. I've found for myself that when you learn one or two particular programs, the ability to learn other subsequent programs is much, much easier, because a lot of them all rely on the same methods and the same approaches to manipulating information and creating three-dimensional forms. A lot of them are free. So many of the Autodesk programs are free or at little to no cost. There are, again, tons of YouTube videos. Most of the programs also have built-in tutorials, which are a really great way to get up and running with them. So I'd recommend if anybody has any questions about which programs were used for what, they can shoot me an email, and I'd be more than happy to walk them through what we use.
That's great. Thank you. So our next question comes from Helene, who says, wow, amazing. When scanning soft, quote, objects like the glove or boot, how do you set them up so they don't slouch down? Do you use some kind of temporary mount?
Yeah, so with the glove, we actually used our typical glove mount display, which was a soft padded Ethafoam structure on a acrylic rod with an acrylic base plate, which is kind of the reason why in the DICOM viewer it showed up the way that it did, as almost like a translucent material because of the density quality of it. A lot of times when we're scanning things, we will create soft cradle mounts for the object to be in a particular position. So a lot of times that's using Ethafoam, or it's using Filara, or it's using polybatting to create a cradle that the object can be held in a particular orientation to help with the scan. A lot of times when you're scanning objects, if you can't get 360 around it, so if it's not something that can be suspended or that you can lift up very easily, you are going to wind up taking multiple different setups and then combining them all together in the scan software.
Great, thank you. And so Jonathan is wondering, if you've actually used 3D printing to make like real actual mounts, and if so, is the material conservation approved?
Unfortunately, none of the materials that we've tested so far have been conservation approved. There are some materials that are, for lack of a better term, less bad. But almost all of your FDM materials, which is the fused deposit material method, which is the cheapest 3D printing approach, and that's what we use for a lot of facsimiles. Almost all of them are thermal set plastics, and they're really not safe. The SLA printing, in which you have a liquid resin that's cured using a laser that has a particular wavelength to it, and then it also goes through a secondary curing process in a UV chamber. Those are less harmful, but they still long-term just are not safe for long-term display. Hopefully, eventually, there will become a 3D printed material that will have a conservation approval. It's just not something that I've come across yet, and we've tested a variety of different materials at this point. So we'll keep looking, and if there is one, then that certainly would be an option. At the moment, most of our 3D printing is to make either a facsimile that then we make the mount directly to, or it's to create a working prototype that then will become machined out of something like aluminum or brass or acrylic. or like those standard materials that we know have a conservation longevity on them.
Great, thank you. Fingers crossed.
Yeah, I mean, every day they're coming out with new materials, particularly in the SLA community. Every day it seems like they're coming out with something new. I just think there's probably going to have to be some sort of push for a material that would have more of a natural inert state.
Right. So our next question is coming from Kimberly, and she's wondering how often you use these sorts of like digital technologies and what the criteria is.
That's a great question. It's not something that we use in every instance. We certainly don't rely on it for things where a simpler, more straightforward approach to mount making would be the best approach. We use it in instances where we are dealing with an object that's particularly complicated, where we think the object is incredibly fragile and we want to limit the amount of handling that is needed in order to complete the mount. We also use it in situations where we might have an object that we, for whatever reason, our timeline and our access to that object is so limited that we just would not have the standard amount of time to develop a mount and test fit a mount. So we will use scanning in that instance to help facilitate the absence of that object, particularly if something's going on loan or if something's going through a very long conservation treatment. Those are instances where we found 3D scanning and also the digital replication and digital mount making has become really useful. But it's a tool. It's a tool that we take out when it's the best tool for the job. So.
Great. And so you find that this means is actually faster than I guess more traditional forms of mount making, the time?
Yes and no.
Yeah. Okay.
It can be the length of time can be much longer than a traditional mount, or given the complexity of a particular object, it could very much shorten the time span. It's really about getting a sense of what sort of commitment you're making, either in terms of the amount of time to scan the object, the amount of time to clean up those scans, and then from that scan data, how quickly are you going to be able to get the best sense of what kind of output you're going to be looking for. Certainly if something's going to be machined on either a CNC or cut on either like a laser cutter or a water jet machine, starting with the scan information is going to shorten the time span between when you took that information and when you have physically something in your hand to work with. So.
Great. And so Earl has a question, and he says a couple of the most important aspects of objects when it comes to designing mounts is the object's weight and its center of balance.
Yep.
How are you compensating for not having this information while designing mounts?
So particularly with like airplane models, we will handle them to determine the CG on it. A lot of times, some of the stuff that we're scanning, there will be original hanging points that we can reference off of. We can also access a lot of the, I'm thinking particularly to like some of the NASA elements or some of the NASA developments. We can also access some of their original drawing sets, and then from there we can kind of guesstimate, I think, in a lot of instances. When we're dealing with aircraft elements that we just don't know, a lot of it's going to be factoring in the volume, which we can calculate from the scan, and then an overall sense of, is this made out of an aircraft aluminum? Is this made out of Corten? Is this made out of sheet metal? Those sort of things come into play. but a lot of it's going to be sort of case by case. One of the things we can do with the CAD software is we can also begin to run structural analysis. So I'm not an engineer. I don't, my training is not in engineering. But when I do begin to design something that I know is going to be reviewed by an engineer, I usually err on the side of overbuilt is much better. So if we're looking at different safety factors, well, you know, I'm almost always looking for like a safety factor of 10, which means the estimated weight of the object and the estimated load of the mount. It would take 10 times that to ever cause the mount to fail.
Great, thank you. And so we have a couple more questions. One is again from Kimberly, who's asking what the size limitations are for
scanning. Or for,
yeah.
So one of the things that's nice with the Artec Leo is that you can scan section by section, and as long as you have enough cross overlapping either geometry or color, you can then stitch those together in the software. So in the instance of the Rolls-Royce engine that we did a week or two ago, I want to say that's 25 or 30 feet long. But the scan section that we took was probably only about a 5 foot by 5 foot section at a time. And we just made sure that each 5 foot section had some sort of overlap with the next one, and then stitched them all together in the software. With some of the smaller scanners, you're looking at, you know, a scan area that's maybe only 3 to 4 inches. Those are, you know, particularly with like the Space Spider scanner that we have, that's a much more higher detail, higher resolution scanner. So those are instances where you wouldn't really want to try to tackle a very large object with that. You would want to focus on objects that could kind of fit within that that 3 to 4 inch parameter. So they do make 3D scanners now that can do an entire room, you know, like a very large room. So, you know, size is quickly becoming no longer a limitation.
Yeah, I remember I was at the Natural History Museum in London, and they were scanning tiny insects and then 3D printing them, so they're much bigger.
That's great.
In the future. So yeah, it's a nice.
Oh, that's great.
So we have another question from Pierre-Luc, who's asking, does scanning affect light-sensitive objects?
I would, off the top of my head, I would say no, but you're definitely exposing it to a light source. So particularly with anything that's going to use a structured light mechanism for scanning, it's going to be strobing a particularly strong light source at whatever object you're trying to scan. So I would say if you're calculating the light exposure down to, you know, minutes of exposure for the lifespan of that object, it's definitely something you would have to factor in.
Great. And Pierre-Luc is following up. He says, did you try a luximeter to measure it? Luximeter.
I've not. That is an interesting idea. I think I'll reach out to our conservation staff and see if we could measure the lux coming off of the various different scanners and get a sense. That's a great idea.
Great, thanks. All right, BJ, how are we for time?
Well, actually, we have a little bit more time for questions, a few more minutes. If there's anyone else has anything. Adam, this is fantastic. And I have to say that this is technology that here at the Getty, we've really started to embrace, and it pretty much has replaced the old methodology of taking paper templates, and
Yeah.
especially for our changing exhibits, for objects that we don't have access to until, just right before an installation. If we have an opportunity, we will try to get out and see those objects, scan them, and then be able to, as you're doing, print one-to-one replicas or parts or sections of the objects that we can work on directly, as an intermediate step to be able to prefabricate things much more accurately. And it's really proven to be a successful method.
That's great to hear. I love knowing that, there's a community that's growing around all of this, and that is embracing all this. It's definitely a new step for a lot of people.
Yeah, I agree. And I think it's something that institutions should really start to be looking at and sharing information, because it's changing a lot, and there's no sense in reinventing the wheel on a lot of this.
Oh, no, absolutely not. I mean, like I said, I learned so much of what I've been doing and what we've been doing. I've learned so much from kind of watching other people and sort of walking through their footsteps and figuring out, where their path is applicable to what, I'm trying to accomplish. So.
Exactly. And it's great to see you using the 3D modeling as well to work out your designs. I mean, I have to admit that's kind of I've become addicted to that as my workflow. It's and to try to think things through dimensionally, and to be able to see things at all different angles, and to be able to move parts and to see the interactions. It's really they've been a huge benefit.
Yeah, it's been really helpful to us also along the development phase of a lot of different projects. So being able to bring people in from the design portion, or from the project management portion, or from the conservation portion, and sort of walk them through the physical 3D models that we're developing regarding either their exhibit or their objects, and sort of explain to them the process that we're hoping to use. It's been really great in being able to give them a visual cue as to where we're going with things, as opposed to a lot of scratching things out on paper. So,
Right, exactly. No, it's a fantastic tool. I'm a huge proponent for it, and as you mentioned, technology is changing all the time and becoming more and more accessible.
Yeah, it's becoming more and more accessible. It's becoming, the price point for a lot of this stuff is going down tremendously. I was just thinking the other day about some of the 3D printers from like the early 2000s, and they were really unreliable, or just really, really expensive, and unbelievably so. And now we're kind of at that same phase with 3D printing in metal, where a lot of them are not, there's not a readily available market solution just yet. But I would imagine in the next probably 5 to 10 years, we'll be seeing that becoming more and more ubiquitous. So
yeah, no, I totally agree. Yeah, it's an exciting time. I really,
it is.
I very much kind of geek out on it. I have to tell you that, I'm sorry, last thing was that I downloaded Armstrong's spacesuit scan.
Oh, cool, great.
It's really cool. If anyone has that opportunity to, it's worth checking that out. It's an amazing look at that object.
Yeah, that whole project was really great.
Very cool. Well, I think we're close to our time. But thank you, Adam. Again, it was really great to hear what you guys are doing and pushing it forward. It's fantastic. Really appreciate all of that.
Well, thank you so much. This has been great.
Oh, okay. Well, fantastic. Our next speaker is Babe Gonzalez from the Auckland War Memorial Museum in Auckland, New Zealand, who is presenting 3D technology for making replicas and mounts.
Hello, my name is Bebai. I work here at the Oakland Museum. And on this presentation, I'm going to be talking about an exhibition that we did last year. It was called Carried Away. And on this exhibition, we shown like 160 bags, all of them from different parts of the world. On this exhibition, we had like 3 special bags. And they have like a case just for themselves. And we were wanting to tell their story. So the exhibition developers came out with that idea of making a video. So for making this video, together with my production manager, we have to do replica of the bag. So just because the actors cannot handle the objects because we have oils on our hands, and also there is more risk of having an accident. So I did this replica of netsuki. Netsukis are like Japanese objects made of ivory or wood. They are carved and they're really detailed. Back on the days in Japan, they used to wear kimonos, and the kimonos didn't have any pockets. So for women, it was a little bit easier because they could put their belongings on their sleeves. But men have like a special pocket that came out outside of their kimono, and they used to wear it with a netsuki. So the netsuki that we were doing for this exhibition, it was a really small one, maybe 60 millimeters by 30 millimeters. And it was a small eggplant made of ivory. So for making the replica of this one, I used a 3D scanner. Here at the museum, we have a 3D scanner of the brand Creaform. So how it works is like the 3D scanner projects lines or lights and shapes and shadows, on the object. So it could get a 3D mesh. It works really well with certain materials like wood or bones. So in this case, the ivory was perfect. So for using this, the 3D scanner also needs like a reference of the position. So we use targets. Those targets are really small, like stickers. That reflect light, so the scanner could know where it is. So the problem with these ones is that they have like a sticky side, so we cannot put them on the objects. So we came with the idea of putting something on the back, maybe some Tyvek or conservation material. It could also even be foam. So you just need to put them over the object, and you could have this reference. Another way of doing it is using like a clear cord, and you can stick those targets on the cord and later put it on your object, maybe like Christmas lights. So that will give a reference to the 3D scanner to know where it is. And obviously, when you're doing a 3D scan, you want a 360 view of your object. But sometimes that is really difficult. So with this specific object, what I did was to make two scans. So first I scanned the front face, and then I scanned the back face. So I had 2 scans that later I could merge. Also, when you are scanning, also the 3D scan takes the information that is on the background. So maybe we'll take the table where you are scanning. But there is programs where you can clean and take all these things that you don't want. The Creaform 3D scan came with a program called BX Elements, where you can do this, and where you can also do the merging of your 3D scans. It also came. You can capture the texture and the color of the object that you are scanning. So if you were printing on full color, it will came exactly the same as the object that you scan. After having my 3D scan ready, I have to do a little bit of post-production on Fusion 360. This is just because the Netsuki had like a small hole that 3D scan could not detect. So I just did this small hole on the Fusion 360, and my 3D model was ready. Here at the museum, we have a filament 3D printer. So we did some tests printing this Netsuki, but we have some problems trying to make it smooth. I tried to sand it, I tried to put in some primer, but at the end didn't work so well. So I think if I were doing it again, I will try to use a resin 3D printer to have a better quality and a better finish. But what we did at the end is just to find a filament to match the color, and we used the highest resolution of our 3D printer. And the results were really good. I just had to do a little bit of carving at the end and a little bit of painting. But yeah, our Netsuki was ready and the results were amazing. Once we have our 3D print ready, we had to do the body of the bag. So the real bag is made of paper. So I was not doing it of paper, so I decided to take some dimensions and make a 3D model on SolidWorks of these small pieces. For making them, I used hardwood because the thickness of the wool was really, really thin. So I was worried about any other material could break. So I used American oak and I sent it to be cut on the CNC machine. The pieces came out really well, and everything was ready to be assembled together. So I used a silk cord that I found on the internet that was exactly the same as the real one, and I attached all the pieces together. And after having that ready, we applied the graphics. The only thing is that when you're printing, it's really hard to get like that gold paint. So I also had to do a little bit of hand paint on the back. And the actors use this bag for making the video. But after that, we also use it for making the mount. So this exhibition was a touring exhibition. So that means that I was traveling all around New Zealand. And in New Zealand, we have a few cities where there are earthquakes. So we had to overthink the way that we were doing the mount. So for making the mount, a coworker called Rick Cave helped us with that. He's a really skilled person on stainless steel. So having that replica helps heaps of having a good fit on your object, and also reduces the risk of handling the object or getting damaged, because you are, I don't know, like with the metals you can damage or scratch the objects, or with your hands, oily hands. So yeah, I think it helped a lot with that. And after doing the mount and the video, we also use it as a prop, because the museum was doing like night tours. So they were explaining to the public the stories behind those bags. So also the public had this opportunity to also handle the bag and feel it. I think this project is a good example of how the use of 3D technology could be the solution for different fields, like using these technologies for the making of replicas that will help with the conservation of the object by reducing the exposure of the object to human contact or light or even the weather. Another one is for display purposes, where it makes the job of Mountmakers more efficient and more precise. It reduces the risk of damaging the object and improves the way we display and handle the items. It's really different to have all these precautions when you're handling a collection item than when you are handling a replica. It gives you more freedom. It also makes it easier to get a better fit and help us to improve the aesthetics of the mount. As another good benefit of making use of these technologies is giving a different experience to the public, using these replicas as props. It's a really nice way to bring an object that otherwise will be impossible to touch to something more real, more tangible, and not just a precious thing behind a glaze case. I think the public really appreciates that. And if you think about it, it's really funny when you think in the context of these objects. And when a Japanese from the 18th century will imagine that someday their Netsuki will be a 3D scan, or they will be even 3D printed. I'm not saying that you need to make use of this technology for all your mounts, but definitely makes your job easier when you know how to use these tools and you applied it. Also, if you're doing really complex mounts, it's a great tool to use. If you have any questions or any thoughts you would like to share, I would love to hear them. Thanks.
Hello.
Thank you, Vivek. That was a really great presentation. I'm sure there'll be a lot of questions. So why don't we start our Q&A?
Hi, thank you so much. That was a wonderful presentation. Very succinct, and yeah, it makes me want to play with these technologies.
Yeah.
Our first question is from an anonymous attendee, and they're saying that they use a program called Vectorworks. Do you think this project could have been done with that program? Are you familiar with it?
No, I haven't used it before.
Okay.
I've used it. And yeah, I think it could. It's very much a compatible program with this technology.
I mean, if you can read like STL files or mesh, I think, yeah, it will do the job.
Yeah, it's a 2D and 3D CAD program that's capable of importing STL files. So yeah, it would work very well for this kind of work.
Great. I have a question about the different types of 3D printers. In our last presentation, we talked about kind of the materials that are used in 3D printing and their compatibility within a museum collections context. I'm wondering, as someone who does not have experience with 3D printing, if you could just talk a bit about like the different materials, like you mentioned there was a resin type. Yeah, if you could just elaborate, that would be great.
I think you could think in why or for what you want your 3D print. I mean, if you want it just to be a prototype, like a filament would be a good one. But if you really need to have a really nice finish, probably the resin will be a nice one. But for example, here on the education team, they use a lot the 3D printing for printing bones from animals to show to the kids. So there is this other powder 3D print that gives like a texture of a bone. So I think it will depend which is the project that you're working on to decide what do you want to use.
Okay. And I have another question. I was wondering about the use of this bag as a facsimile to engage museum visitors. I'm wondering how often you have to reprint that facsimile if it's handled quite a lot from the like how does it withstand well being handled?
Yeah, actually, I didn't have to reprint it or anything. It just it went through all these scans and it's still intact. We still have it and it still looks good. I mean, yeah, with this print and it was anything fragile with it, so it was really good for handling. But I imagine that, I don't know, probably, I'm not saying that all the objects, maybe you have some objects that have like really small details that could be easily to break, but not in the case of this one. It was just perfect to handle, and yeah, nobody broke it. And also we use PLA, so it's plastic, so it's really hard.
Okay. I do have another question about, well, I guess I just think about kind of my experience as a conservator and the kind of privilege I have with handling objects and, you know, using my other senses like touch and smell and yeah, just to feel how heavy an object is. I'm wondering what the weight is, like the 3D print compared to the original object, like how close are those textures, like how comparable is the weight, that kind of thing.
Well, I don't think it could compare the Netsuki with the real one because that one was ivory, so that is a little bit more heavy than can we get on the 3D print that was lighter.
Mm-hmm.
So probably in that sense, you don't get that experience of the weight. Or,
but as a Mountmaker, is there any way you could have some kind of intervention to kind of make it a bit?
I think yeah, definitely. I could do like, instead of having like a hollow 3D printer, I could have the side to be solid. So maybe I could have make it heavier. But I never thought about that. But actually, yeah, it's true. Like it's something related with experience for the public, like to feel the real weight of the thing. And with the body of the bag, it was made of paper, so it was really light. And the one that I did on wood, it was also light, so maybe that one was a little bit more similar on weight.
Nice. I also really liked that you went in and in-painted afterwards.
Yeah, actually, that was a little bit of hard work.
Yeah.
Yeah.
And so I'm just seeing that there's some questions coming in. So I'm just going to move on. The first question is from Karen, and she's wondering what time it is in New Zealand.
It's 11:03 a.m. from the 28th of October. So we live on the future.
There you go. And so Joe Dickinson, hello, Joe. They're wondering, is there a way to weigh a 3D printed object so that it is comparable to the original to further aid mount making?
Can you repeat the question? If we can...
Is there a way to weigh a 3D printed object so that it is comparable to the original to further aid mount making?
To weight?
Yeah, I guess so.
I think, yeah, you definitely could weight it and could compare. I don't know, you could compare, I don't know if I'm putting as example this Netsuki, I could compare doing different tests of 3D print and see which one could be more similar to the weight. You have some settings on the program of your 3D printer where you can choose how much structure inside you want to have, or if you want it hollow, or if you want it all solid. So that could help you with the weight of your 3D print. Also, you could find another ways of feeling it. I don't know, with resin or with another thing to make that balance with the weight.
Great. I realize now that it kind of tied into my last question. But so the next one is coming from Emma Smith. And they're wondering, what do you do with the facsimiles after they're used? Are they kept long term?
Yeah, they keep them because sometimes this exhibition also, like, not the whole exhibition, but it tours to schools. So maybe some images or the props also travel with that itinerant exhibition. So we keep them. We keep all the props that we do.
That's great. Thank you. And we have another question from an anonymous attendee who says, you mentioned the original bag for the object being made out of paper, but for the replica you went with oak. Is there any reason you went with wood instead of a sturdier paper imitation like Tyvek?
What I did that is because I'm 3D model on a 3D program, and I did it on a CNC machine. So yeah, with paper I will not be able to do that. It was just to get it a more precisely, yeah, to make it more precisely at the real one. So that's why I use wood, and that's why also I use like hardwood, because the wall thickness was really thin, so I had to make it stronger. So that's what I use, wood. And also, yeah, just to make it harder, because I also it will be a prop, so it's easier if it's paper probably to be destroyed by kids or the public than if it was wood.
Great, thank you. And so our next question is from Kate, and they're wondering, well, they state first, we use some 3D printing and some hand sculpting and molding. How do you decide at your institution which technique to use? Is it a time or cost decision?
Probably that was a little bit more of time, because we had to do like a lot of, yeah, that exhibition was a lot of objects. We had to do 160 mounts for that one. So I thought that maybe using the 3D scan will be quicker way to do it. Yeah, maybe that was quick, but what took more time was like waiting or to send it to be done by someone else, by the, yeah, waiting the suppliers to come back with the results. So maybe preparing the 3D model and the scanning was quicker than waiting. But yeah, I think this time we did it by the timing, not for the price.
Great, and that kind of just ties into Sam's question, who's just wondering how much time you spent carving the detail on the 3D printed replica at the end.
That was a little bit of time, because I thought that will be easier. I thought like, I don't know, it's just like carving wood or something. But actually, when I was using the Dremel on the 3D printer, like the plastic started like melting. So it was not working actually how I expected. So I had to print a few of them and make some tests. So yeah, that took me a little bit of time also for practicing, and yeah, to get the real, like, well, I mean, like the more similar one. But I don't know, I will say, I don't know a timing exactly, but it took me a lot of time, like to printing more, yeah, just for replace the one that I screwed.
Great. So we have an attendee that says, thank you for sharing such a beautiful and exciting project. Documentation question. It's awesome that the museum found so many uses for the replica. Is there a note put in a database somewhere so that your colleagues across the museum know a replica was made and is available?
Actually, I'm not sure about that, but this project has been like shared, because was one of the first time that we were using our 3D scanner for doing a replica. So I think definitely people from another departments like approach to us when they want to do 3D scans or 3D prints. And also we have like a folder with all those 3D models that we have done before, so we share it. Also we have yeah, like an open source website where you can download those 3D models that we already have scanned from things.
Oh, that's great. Nice. And so we have another question from Sean, who's asking, is there a corrosive that can help with the printed texture instead of sanding?
Corrosive.
Yeah.
Not really. Well, I mean, I try to use the primer as I was saying on my video, but you have to give a lot of layers. And there is anything like really melts PLA. Maybe if you use another plastic, it will do it. But yeah, no, not that I know.
Okay. So we have another question from Joe Dickinson. Did you feel that the limitations on getting the detail of the Netsuki, which necessitated additional carving, were more to do with the scanning process, software, or the printer?
I think it was a little bit more of the scan. I mean, I think it's a really good scanner, but we were doing like something really small for his capacity. So I think maybe with a better scanner, you could get a better results. But definitely, I think was our 3D scan, the one that couldn't get so fine detail, that was really, really small. So probably if you're using another scan for small things, because actually we have two scans, the one supposed to be for big things and one for small things. But the one for small things doesn't work really well. So I use the one for big things. And even the ones for big things, I think it captured really well, at least the essence of the shape. Yeah, but with those small details, it couldn't detect them.
Okay, thank you. And so I'm going to steal one of Laura's questions from yesterday. If you couldn't go digital, what tool can't you do without? What mount making tool?
Without being digital?
Yeah.
Oh my God. Think I think a soldering machine. Yeah, to weld things.
Great. Thank you. How are we doing for time, BJ?
I think we have a couple minutes left. I just wanted to say that I appreciated the point that you brought up of being able to use the printed replica for aiding in the layout of the exhibition and the installation of the mount in lieu of extra handling for the object. I think that's a great aspect of using and having printed models available. And I was glad to see that you utilize that. That's great.
Yeah, definitely. We always have like this opportunity to touch the objects that nobody can do. But yeah, you never think when you go to a museum that you're gonna have this opportunity to feel it. So I think that's a really cool thing to do with these replicas.
Yeah, I agree. It sort of serves a second purpose, or a third purpose, maybe beyond your original intention. But it's great, and I sound like I'm selling 3D models, but I think it's great that you can utilize this technology for more than just one application. So yeah, a very, very cool project, and thank you for sharing with us. Really appreciate it.
Cool. I'm glad to be here. Thanks,
Excellent. So our last presenter for the day is Tom Beeson, also from the Auckland Museum in Auckland, New Zealand, who will talk on displaying a leatherback turtle amongst a sea of rubbish.
Kia ora, ko Tom Beeston toku ingoa, kei te mahi ahau I Tāmaki Painga Hera. My name's Tom Beeston. I work here at Auckland Museum in Aotearoa, New Zealand. And I'm going to talk to you about a case fit out we've been doing, which involves a leatherback turtle shell floating through a sea of rubbish. Like anything, a lot of people have been involved in this, and there's a lot of ideas and stuff come into it, but for some reason, as the maker, I've been allowed to take the credit on this occasion. So the case I'm talking about is for a gallery with a working title of Learning Base. The gallery is designed to act as an entry point for school groups. So it's really an introduction to the whole museum collection. There's a broad variety of objects in there, which is to inspire curiosity about connections between objects where you might not expect there to be connections. And the scale of the objects, they've chosen large objects, and these 4 cases are really large cases, and that's deliberately to inspire curiosity with the use of spectacle. So I'm talking about one of these 4 cases. So the rubbish for this case was collected from the same beach where the turtle shell was found, so the connection here is obviously quite real. And the aim was to make the turtle appear to be swimming through this rubbish as if it was in the sea. So the brief for us down here was essentially to make a mount for the turtle shell and a mount for about 350 pieces of rubbish. While the rubbish is not collection items as such, they were collected and they are therefore one-off, and the same sort of care will be needed in the mount making. So the ideal scenario was to make the rubbish appear to be the surface of the sea, with minimal mounting structures visible or obvious. So one idea that was floated for this was to use fishing net and somehow make that rigid and be able to support the rubbish. But that idea was ditched because it introduced fishing net as a whole another concept that wasn't really helpful in the story they were trying to tell. Another idea that I quite liked and took quite far was to use straight mounting rods and make them appear like shards of light shining through water. I took this idea quite far and actually had a CAD file ready for 5-axis CNCing a base panel to support the rods at the right angle, and then all we'd have to do is know the length and cut them to the right length, and they would all meet at the surface, and then they would be quite nice points to mount the rubbish. That idea was ditched because it was seen as a bit too much of a spectacle in itself as compared to the objects. So at about the same time, the developers decided that there would be a theme across all 4 cases of having sculptural elements made out of laser cut stainless steel. In this case, that sculptural element would be the surface of a wave. So the production manager, Nick Shah, drew up the 3D form of that wave in CAD software. And so everyone was happy with the wave he drew, so that's the form I've been working with through this project. I looked at lots of images of surfaces of water, oceans and seas and such, but with a view to finding something that you could turn into an image that you could cut from a sheet, and that would represent water. What I actually ended up using was images of swimming pools, because while that's sort of still water, it actually presented an image that you could cut and was still very suggestive of water. It also gave quite a nice mesh pattern that you could scale, and we could adjust the holes to a degree to suit the rubbish that we were expecting to mount. And the other advantage I thought at the time was that you could make it quite a thin mesh, and that would allow it to be formed to a compound curve that we had as the wave. As I went along, I decided that that was probably not the best approach. It needed to be strong enough to support itself. So what we would have to do was actually to come up with a two-dimensional net shape that we could cut into the ripples pattern and pull it back together with cut darts into it, pull it back together, and that would form the curved dome of the wave. I drew the ripples, or traced the ripples up in a 2D vector software, and then I introduced the shell into that drawing so that I could see how it might interface with the water, morphed the ripples to look like they were flowing around its edges a bit more, and then actually created an opening in the kind of upward sweep of the wave where the tail would be actually physically interfacing or tucking in to the wave. Unfortunately, our collective skill set on the CAD software didn't stretch to unfolding a three-dimensional curved shape. So I took the approach of card and paper, made some upright formers out of card derived from the CAD file, so that I could lay the paper over that and then cut darts into the paper until it came together over that form and sat nice and comfortably on that former. So I then scanned that piece of paper into a well-known photo editing software, took my ripples pattern and smudged it to fit that net. I also used this smudging process to stretch the mesh pattern where it crossed over the dart openings so that when it came together it would fit better. And then I had to retrace that in the vector software, and then I actually cut the darts out in the vector software, but carefully made sure that when it was brought back together, the flow in the ripples pattern was still there. It didn't have jagged joints. At this point, I also made the joining tabs that would pull all the parts together. So I extracted these from that same drawing, keeping the holes all nicely lined up so that there wouldn't be any problems once they were threaded for the little stainless steel bolts. This then needed to be tested at small scale, and I decided the easiest way to do that was actually to 3D print it, even though it's a 2D object being folded into 3D. It gave a nice flexible material that could kind of represent the 3 mil stainless that it would be, and it saved a lot of cutting basically. We separated the mesh out into parts to make it more convenient for assembly when it was at full scale, and these parts, once I scaled them down to 1/6 size, and they fitted nicely onto the bed of the printer, and so that's the scale I went with for the scale model. So once this sat nicely over the formers and seemed to come together nicely, it seemed to be any other way of testing it. So we pressed ahead and ordered the stainless. Once at full scale, I used 12 mil MDF as the formers, spaced out across the base panel dimensions, and then got to work wrestling that 3 mil stainless steel onto it. We used wrenches and clamps to try and bend it to shape, and the occasional hammer, and it seemed to just be coming together. There was just one bit where it couldn't quite get it to come together, and used a actually ordered a longer joining tab and a little infill tab, but everywhere else it seemed to work nicely. And once it came together and we bolted the uprights on, which had the correct angle at the top, it all seemed to be nicely self-supporting. So we raised it off the formers by about 50 mil, just enough to give us room to mount the rubbish, with the occasional cutting away. But we wanted to keep the formers there so that we could use that structure as a support when we were moving it around the galleries to take it to the gallery eventually, because we'd need to tip it on its side to fit it through doorways and such. So then it was time to start mounting the rubbish. As I said, we're aiming to have the surface cutting through all the rubbish at what we imagined would be the floating level. I did a small test of this just to make sure the approach was going to work on similar kinds of rubbish. But once it came to doing the final thing, there was only kind of one shot. So I was working to layout of the rubbish that the curators had done, and I had a photograph of that layout with my mesh superimposed on it to work to. It was a bit of a process, but as you can see from this video, I did it all in about a minute. No, it was more like 4 weeks with all the usual distractions of working in a museum. Mostly it went well. At the beginning I could have done some of them better, but each object pretty much needed a new approach because they were all so different. But it seemed to go quite well. I'm quite pleased with how that came out. As you can see, there's quite a range of interesting bits and pieces among the rubbish. So I had some fun deciding how they might float and where to cut them. A few kind of local and international brands represented there, which was interesting, and whether to show that or not, but we just went with whatever it was and whichever way it seemed to be happy floating. The glue we used was called Paraloid, which is acrylic dissolved in acetone. It's got quite a nice user-friendly drying time, and once gassed off it's conservation friendly, and supposedly it's completely reversible, probably depending which plastic you're gluing, but fortunately that didn't eventuate. I didn't need to test that. We wanted some objects to be floating subsurface or mid-water, so I used kind of monofilament and threaded some steel through some things to make them hang, but not just be hanging down in space, make them look like they were floating. So the formers allowed us to move it around, but what we needed to get it into the case, we made a stretcher to pick it up from the tops of the uprights and spread the load nice and evenly so it wouldn't deform when we pick it up. And that would allow us to slide it in using a forklift, slide it into the short end of the case, which is the door, and just drop it, and we can guide the uprights into their holes in the base panel. It would be nice to show you the finished thing, but unfortunately it's not installed yet, and it's pretty busy here, so I don't think I can ask enough people to get the turtle shell out and mount it. So you just have to wait and see, I'm afraid. The best I can do is this image we took when we assembled everything to check that it would all fit together. That was a while back. But yeah, thank you for listening, and look forward to your questions. Ka kite anō. Hello.
Hi, Tom. Thank you so much. I first want to say how great the title of your talk is. It's very poetic. And at the end of the day, it is literally rubbish around a turtle. Very cool project. I have a question for you first. Let me just pull up the Q&A thing. So I'm wondering if you had any, it's more of a design question. I'm wondering if you had any discussions around coloring the structure, make it more watery, or what was your choice of leaving it as raw aluminum? Your stainless steel, sorry.
Yeah, no, there was a lot of discussion. I'd sort of touched on a few ideas that went, like the idea of using a fishing net as that surface, and then I talked about the shards of light kind of idea. But the stainless had always been an idea that was there in the background, different potential different ways of doing it with stainless, not necessarily that final idea. But eventually, when I did mention this, there's that whole suite of cases, and they decided that they needed something to tie all those together visually. And this idea of kind of sculptural stainless steel came up, and it was widely supported. And so we kind of channeled this problem down that route, and this is what we came out with. So there's like a tree bark representation that we've done, which is kauri trees, which are quite well known New Zealand tree, and that's telling a story about whales and trees, a kind of myth, a Maori myth. What other ones? Oh, and there's another wildebeest case, a case with a wildebeest in, and we've used the stainless steel to represent the dried up earth that it might be standing on. So it's, they've tied it in. This stainless laser cut stainless steel appears in all four cases.
Great. And we have attendee that's kind of chiming in and saying that water is a very tough effect to capture. And you said the light shards were nixed. But was there talk of using gallery light and other ways to give a water effect?
There will be gallery light adding to this. It will just be over the top. They're using, I can't remember, Wayne's a man, but is it a moving gobo kind of thing to accentuate that kind of gentle ripple of water? So we will be using gallery light to aid it as well, yeah.
And I'm wondering, so before you started this project, was the rubbish collected? Like, did you know what trash you were working with, or you kind of integrated it after?
No, it was there the whole time I've been working on it. It was collected by a not-for-profit called Sustainable Coastlines, who campaign against kind of plastic getting into the oceans and such, and they quite often do litter picks. And this was the rubbish collected from one of those litter picks. So it was there all the time. It was kind of wrapped up safely, double bagged for quite some time before we got round to deciding how it was going to be cleaned, because it's obviously in the same case as a collection object. So we knew we had an idea, and I'd looked at it, and it was, had an idea of roughly, basketball being the biggest thing, and there was lots of bottles, and then lots of little bottle lids and straws, and so I had an idea of the scale and the type of object as I was developing it. Something else I was going to say then, but I've completely forgotten. So and then some stuff out of that collection of rubbish did have to be picked out because the conservator was wary of kind of plastic degrading, and both it just not existing and also the gassing off potential of some plastic. So it's not completely representative of what was found, but it's a good attempt.
And so you, for this project, you worked with this eco group, you worked closely with the curator. Can you talk a bit about like the kind of collaborative practice towards, I mean, the Mount is really what kind of ties together this piece, right? Could you talk about the collaboration a bit?
Well, there's all sorts. I mean, there's I don't know if I'd call myself a Mountmaker. I've been at this museum for 2.5 years, and before that, I had no idea about mount making.
Mm-hmm.
So the mount for the turtle was made by colleague Chris Sheehan, and he collaborated with another colleague to do a 3D scan. They actually 3D scanned the inside of the skin to develop a mount. And then, to come to this design outcome, it was curators, exhibition developers. It was just, quite a collaborative process, and it was quite slow. I was working on lots of other things. This was trickling along as ideas for quite a long time before we actually got stuck in and went with this idea. So lots of meetings. The sustainable coastlines were that was all done before my time. So I mean, I don't know how long this gallery has been in development, but just the idea of combining the turtle shell with the rubbish was before my time. That was
okay. And so we have a few questions from Karen, who is asking, once this is installed and open, how long will this be on display? And she is also asking how the turtle shell is being supported.
Okay, so it's 10, I think it's 15 years they're aiming for with this display. And I don't know if the shell will have to be rotated out over that time for, light exposure purposes. I'm not actually sure about that, but the whole thing as a whole has a 15-year life expectancy. It'll probably be there longer than that. It's definitely a permanent gallery. And supporting the turtle, that was not my job, but I can talk about it. They took a scan like the previous two presenters would have done, and derived sections from that scan to make ether foam ribs along its length, and then that's supported on a panel, and then there's just a single upright rod onto that, so that we can pass it in and drop it down. So that will go in after the rubbish wave is installed into the case. We'll then put the mount in place, and then we'll be able to offer the turtle shell onto that mount. So there's quite a lot of discussions about the process and the order we were going to do that. I don't know if that answers enough about supporting the turtle shell.
Yes, and Karen says 15 years, wow. Long time.
Yeah.
So we have another question from an anonymous attendee who says, thank you. And goes on to say, you might have mentioned, but were you given free license to arrange the garbage? There were a lot of colors and shapes, the pieces hanging down. It's funny how much effort can go into making something look random.
Yeah, that's, no, that was another meeting was had to arrange the rubbish, and there was 5 or 6 people there. And an idea sprang up at the time to arrange the rubbish roughly in color, like a rainbow. And that somehow that idea stuck as a way to they wanted to make it look more attractive. What's the word? There's a way to draw the eye, really, so it didn't look too kind of brown and, so it stood out more. So the rubbish was actually arranged randomly, but in roughly color-coded arrangement. And so I did have a photo of that I was working to while I was mounting all the rubbish. I had to get it roughly. I mean, they weren't too fussy about it, but roughly in places there that we'd agreed on, so there was no kind of argument after it happened. Yeah.
Great, thank you. And so we have a couple more questions coming in. One from Helene, who also agrees this is such a nice project. And she's wondering, how high up in the display case will the wave be? Will the bolts be visible, mainly for children, or did you hide them somehow? I guess concern for children.
No, the bolts, you mean the countersunk bolts that hold the thing together?
Yeah.
They'll be visible. So it's kind of the highest point is about a meter, and the lowest point of the wave is about 400 off the ground, but off the base it's about 250, I think, from memory. So you can, as a child, you'll be able to see underneath it and above it without having to bend down. As an adult, you'll be able to hear underneath as well. So yeah, we didn't attempt to hide the bolt, and the bolt heads on top of the uprights as well. The uprights will be matte black, so they'll sort of disappear a bit was the aim, but yeah, not really an attempt to hide anything, just make it tidy. Yeah.
Great. Well, lovely work. BJ, how are we doing for time?
I think that pretty much, I think we've used our question and answer time. Tom, this was a great presentation and a fantastic example of how to utilize 3D technology, not only in the design aspect, but prototyping and working out the different aspects of the display. Really, really good stuff. Thank you so much. Wow, thank you to all of our presenters. What a fantastic day of presentations and discussions. I think there's a lot to think about, but great stuff, and really happy that everyone could take a part in this. Our after party will be starting shortly at 7 p.m. Eastern time. It's a great place for to get together for some informal chatting. None of it will be recorded, so no worries there. If you haven't registered yet, you can still do so at mountmakersforum.net. And I hope to see you there. Thanks, everyone. Great second day, and looking forward to the next few days that we have. Bye.